In this video, I'm going to be dealing with implicit differentiation. So if you have an equation that consists of more than one variable of different kinds, we consider that equation as an implicit equation. So out of that, for example, if I have been given I have x squared plus 2y squared minus 2x minus 2y, that this would be equals to 3. So this is an implicit equation because I'm having x and I'm having also y as variables. So out of that, what I can do here, but I'm going to be differentiating this with respect to x. To differentiate this, if I differentiate, for example, y with respect to x, with what I remain with will be the y dx, because I'm differentiating with respect to x in this case. So for the to get the derivative of this, what I'm going to do, if I differentiate x squared, I'm going to get 2x, then plus what I'm going to get here, this is 4y, but what I'm going to get here will be the y dx, because it is with respect to x. So minus what I'm going to get here, this is going to be 2 minus 2 dy dx, which would be equals to 0 because 3 is a constant. The next thing here, I'm going to have 2x. Now let me collect those that are alike. So minus 2 plus 4y dy dx minus 2 dy dx, which would be equals to 0. So here I'm going to have 2x minus 2, close this, and I'm going to have plus 4y minus 2 dy dx equals to 0. So out of that, let me take this beyond the equal sign. So I'm going to have 4y minus 2, close this, dy dx would be equals to, if I take this, I would have a negative to 2x minus 2, close this. Now let's divide throughout. So divided by, so I'm going to divide this 4y minus 2, close this, divide by 4y minus 2, and so I cross this with this. So our derivative would be dy, let's say if I have dy dx, therefore dy dx would be equals to negative 2x plus 2 divided by, I would have 4y minus 2. And if I have x power 4 minus 4xy plus y cubed plus y squared, that this would be equals to 10. And so the next thing here is that if I say I differentiate x power 4, I'll get 4x power 3 minus, now I keep the 4 constant in this case. Now product and quotient rule, I would say this would be y into, I would have 1 plus, I would have in this case x and a dy a dx, because I'm differentiating y with respect to x. Now plus I have this, of which this would be 3y squared dy dx, yes, and plus 2y dy dx, and this would be equals to 0 because 10 is a constant, and therefore I'm going to have 4x cubed minus 4y minus, I'm going to have 4x dy dx now plus 3y squared dy dx plus 2y dy dx, and this would be equals to 0. And so the next thing here, let me collect the like terms. So I'm going to have 4x cubed minus 4y. Yes. And so here I'm going to have plus, I'm going to have negative 4x plus 3y squared plus 2y dy dx would be equals to 0. And so the next thing here, I'm going to take the whole of this to the other side. So I'm going to have, so negative 4x plus 3y squared plus 2y, close this, dy x would be equals to, now if we bring this would be negative 4x cubed plus 4y in this case. So our dy dx would be equals to negative 4x cubed plus 4y divided by, I'd have here negative 4x plus 3y squared plus 2y. Therefore, to work with this properly, so dy dx would be equals to, here we're going to have something that's going to be, we would have 4y minus 4x cubed all over, this is going to be 3y squared plus 2y minus 4x in this case, and therefore this should be our derivative cos of 2xy, and this would be equals to 1 if I've been told to differentiate this. So what I'm going to do here, differentiate this, I'm going to say I'm going to have negative sine of 2xy, let me enclose this, 2xy, and therefore then for the inside part I would have, now to differentiate this I can keep the 2 constant, and then I'm going to have y into 1, close this, plus I'm going to have x dy dx and close this. So the whole of it would be equals to 0, because if I differentiate this I get a 0. So this is going to be negative sine of 2xy and close this into, this is going to be, I'm going to have 2y plus 2x dy dx, and this would be equals to 0. And so let's multiply these throughout. I'm going to have, this is going to be 2y, which is going to be negative 2y sine of 2xy and close the whole of this, minus I'm going to have 2x 2x sine of 2xy and close the whole of this, and we're multiplying this with this now. So this is going to be, having got so, but we are having our dy the x on this, it's going to be equals to 0. Therefore let's take this beyond the equal sign. So negative 2x sine 2xy dy dx would be equals to, I would have here, this would be 2y sine 2xy. Now let's divide throughout by this. So divide by negative 2x sine 2xy and close this, and divide this by negative 2x sine 2xy, and so this would go with this, and so my dy dx would be equals to 2y sine 2xy and close this all over negative 2x sine 2xy. But the way we see this, these can cancel with that. Therefore, you're going to have something that the y dx would be equals to, so 2 goes with the 2, I get 1 1. Yes, the sign goes with the sign, and therefore I remain with on the y. So with the negative, I'm going to remain with negative y all over. We're having also our x down here, so this is going to be negative y all over x in this case. Therefore, this is our derivative for this. And so if we have x all over y cubed, which would be equals to 8 x in this case. Now, to differentiate this, I'm going to use product and quotient rule. So I'm going to have y cubed into 1 minus, I'm going to have x into 3y squared by dy dx, and close this all over. I'm going to have y cubed but squared, and this would be equals to 8. So out of that, the next thing here is to arrange this. I'm going to have here, this is going to be y cubed minus, I'm going to have 3y squared x dy dx equal to 8. So, but the whole of this, I'm going to multiply this to this side. So I'm going to have y, this is to power, this is going to be power 6. So out of that, next thing here that I'm going to do, I'm going to take this the other side. So 3y squared x dy dx, but this is negative, would be equals to, I would have 8y power 6. Now I take this the other side, which is going to be minus y cubed. Having got so I'm going to divide throughout, divided by negative 3y squared divided by negative 3y squared. And so here I'm going to have this going with this, and so dy dx would be equals to, I'm going to have, now if you look here, I'm having y throughout, so this is going to be I'm going to have 8, so y squared, so this is going to be y power 4 minus, this is going to remain as y all over negative 3 in this case. So out of that, dy dx would be equals to, I'm going to have, this is going to be negative 8 y to power 4 plus y all over 3, of which if I arrange this, so dy dx would be equals to, would have y minus 8y 4 power 4 divided by 3, and therefore this is my derivative. So if I have also 7y squared plus sine 3x equals to 12 minus y power 4. So here I'm going to say this is going to be 14y dx plus, I'm going to have, so this is going to be cos of 3x into, this is going to be 3, which would be equals to, I'm going to have here, this is going to be 0, this is going to be negative 4y power 3, because this is going to give us a 0, and if we differentiate this, we are going to get negative 4y cubed but dy dx. So let's bring this, so let's bring this side and take this the other side. So 14y dy dx plus 4y cubed dy dx would be equals to negative cos 3x 3x, but we are having it's being multiplied by a 3, so 3 negative. So out of that, what we're going to do here, and so we're going to have 14y plus 4y cubed plus this, having the y, the x would be equals to we're going to have negative 3 cos of 3x. So out of that, we are going to have the y, the x being equals to negative 3 cos 3x all over what we're going to have here. This is going to be, we are dividing throughout, so 14y plus 4y cubed in this case. Therefore, this would be our derivative in this case. Tan x squared y to power 4 equals to 3x plus y squared. And so this is going to be sec squared to x squared y to power 4. Close this into what I'm going to have here. This is going to be y to power 4 into, this is going to be 2x, close this, plus I'm going to have now x squared into, this is going to be y 4y cubed dy dx, close this. Now having got so, and this was being equals to, I'm going to have 3 plus, this is going to be 2y dy dx. And so I'm going to have here, this is going to be sec squared into x squared y to power 4, close this into, I'm going to have 2x y power 4 plus, I'm going to have, this is going to be 4y cubed x squared dy dx, which would be equals to, I'm going to have 3 plus 2y dy dx. Now let's work out this, and then afterwards so this is going to be, if this multiplies in, I'm going to have 2x y to power 4 sec squared into x squared y power 4, close this, plus I'm going to have here, this is going to be 4y x squared, we're going to have sec squared x squared y to power 4, and close this. Then we are having our dy dx, so dy dx, and this would be equals to 3 plus 2y dy dx. Now to collect like terms from here, what I'm going to do is I'm going to take this beyond the equal sign and collect these also together with this. So I'm going to have 4y cubed x squared sec squared x squared y to power 4 dy dx, and bring this also minus 2y dy dx, and this would be equals to, I'll remain with this 3, yes. Now minus 2x y to power 4 sec squared x squared y to power 4. Now having done so, next thing here is now So my dy dx into, I'm having this 4y cubed x squared sec squared x squared y to power 4, close this, minus, I'm having 2y, this would be equals to, I'm having 3 minus 2x y to power 4 sec squared x squared y to power 4. Sort of that, dy dx would be equals to 3 minus 2x y to power 4 sec squared x squared y to power 4, close this, all over 4y cubed x squared sec squared x squared y power 4 in this case. Therefore, this would be my derivative in this case. Y cubed plus x cubed y squared, this would be equals to 0. And so this is going to be 3y squared dy dx plus, I'm going to have here, this is going to be y squared into 3x squared plus, I'm going to have in this case x cubed into 2y dy dx. So put this together, so here this would be equals to 0, of course. So this is going to be 3y squared dy dx plus, this is going to be 3x squared y squared plus, I'm going to have 2y x cubed dy dx, this would be equals to 0. And therefore, what I'm going to do here, this is going to be 3y squared 3y squared plus 2y x cubed, close this, having dy dx, this would be equals to negative 3x squared y squared. Therefore, dy dx equals to negative 3x squared y squared all over. So I'm going to have 3y squared plus 2y x cubed. And therefore, since I'm having y is common throughout, so dy dx would be equals to, I would have here, this is going to be negative 3x squared y all over 3y plus, this is going to be 2x cubed in this case. Therefore, this would be my derivative in this case, squared plus y minus x cubed equaling to 9. So what I'm going to do here, this is going to be 2x plus, this is going to be, we're going to have 3 to y minus x, this is going to be then into, we're going to have this is going to be dy dx minus this is going to be 1. Close this, and this would be equals to 0. Therefore, I'm going to have 2x plus, now multiply these throughout, so this is going to be 3y minus x dy dx. So multiply this all throughout, minus 3y minus x. But this was having a squared here, this was also squared, and therefore this would be equals to 0 in this case. So what I'm going to do here is now to bring this, say that 3 to y minus x squared dy dx would be equals to, so I'm taking this and this beyond the equal sign, so I'm going to have 3 into y minus x squared minus 2x 2x. So having done so, the next thing here is I'm going to say dy dx equals to 3 into y minus x, but this is going to be squared minus 2x all over 3 into y minus x, but this is squared, and therefore this would be my derivative in this case.